Hello students of grade 11. Today we'll do mathematical reasoning exercise 14.3. This is both for maths and applied maths. First question, for each of the following compound statement, first identify the connecting word and then break it into a component statements. Now the statement given here is compound and we're going to break it up into two statements. And you have to find the connecting words. So connecting word can be or, and. Okay. Now first you find the connecting word for this question. Connecting word will be all rational numbers are real n. So connecting word is n. All real numbers are not complex. So they have given two statements. You have to break into the component statement. So component statement, first statement will be, suppose I write P is the first statement, can say all rational number are real. And the second statement will be all real numbers are not complex. So similarly you have to do the second one. First find out the connecting word. So connecting word is and or, okay. So here connecting word is or. And the component statement are, first statement we can say square of an integer is positive. Of an integer is positive. And the second one will be square of an integer is negative. Similarly, we'll do the third one. The sun heats up quickly in the sun and does not, so here connecting word is and, does not cool down fast at night. So connecting word will be what is and the component statement, first statement will be the sun heats up quickly in the sun. So you can write the sun heats up quickly in the sun. And the second statement Q will be the sun does not cool down fast at night. Let's do question number 4. X equal to 2. So connecting word is n, and x equal to 3 are the roots of the quadratic equation. So we can say connecting word will be n. So component statement will be P. We can say the x equal to 2 is the root of the equation 3x square minus x minus 10 equal to 0. And second one statement Q will be x equal to 3. You can write the statement is the root of the equation this. Write as it is, okay? So this is question number 1 is over. Let us do question number 2. Here, identify the quantifier in the following statement and write the negation. Negation means the opposite statement you have to write. Now, what are the quantifier? Let me explain. Quantifier words we use are for every, or for all, or there exists, or there does not exist. These are all quantifier words, okay? And negation means you have to write the opposite of the statement. Now, identify the quantifier words. So, quantifier will be, here will be there exists. So, there exists is the quantifier words, okay? Now, you are going to find the negation. Negation means the statement you have to write the opposite of this statement. There exists a number, they have given there exists a number which is equal to the square. So we can say there exists a real number so negation means you have to write the opposite. So we can write there does not exist a number which is equal to its square. Negation means you're writing the opposite of whatever statement is given. Let us check the quantifier in the second question. Here quantifier is for every. Let us write the negation of the statement. What is the negations here? Instead of for every real number x, x is less than x plus 1. So we can write there exists a real number x such that x is not less than x plus 1. Okay, let's do question number 3. There exists a capital for every state in India. So here quantifier is there exists. Let us write the negation. We have to write the opposite of this statement. There exists a number, so you write there does not exist a number. Or we can say there exists a state in India which does not have a capital. A capital in India which does not have a capital. Okay, let's do question number 3. Check whether the following pair of statement are negation of each other. Give reason for your statement. You have to say that whether they are opposite to each other. Statement 1 and statement 2 are opposite or not. So they said x plus y equal to y plus x is true for every real number x and y. And the second statement is there exists real number x and y for which x plus y is equal to y plus x. So both the statement are meaning the same. That means they are not negation of each other. 1 and 2 are not to each other. So what will be the negation? So explanation you can give. Negation of statement 1 can be is, the statement 2 must be there exists real number x and y for which x plus y is not equal to y plus x. So this is opposite of the first statement. So negation of the first statement can be there exists a real number x and y for which these two are not equal. So this is the negation of statement 1. Let's do question number 4. State whether the or used in the following statement is exclusive or inclusive. Now, or can be exclusive and inclusive. When you say exclusive, suppose they have given two statements. Exclusive means these two statements cannot happen at the time. And inclusive means can happen, anyone can happen at a time. For example, sun rises or moon set. Here or is exclusive. Why? Why or is exclusive? Because only one situation can happen. One of the two can occur. Either it will be sunrise or moonset. It cannot be together at the time. So these two occurrences cannot be possible. That's why. Let's say to apply for a driving license, you should have ration card or passport. So this is inclusive. Why inclusive? Because if you have ration card also, you can have a driving license. If you have passport also, you can apply for a driving license. So we can say both situations can occur. That's why we can say the or is inclusive. Why? Because you can apply for a driving license when you have both the ration card and passport. If you have both also, you can apply for driving license. If you have this also, you can apply for driving license. So this is inclusive because both are taken into consideration. All integers are positive or negative. So this will be exclusive. Or is exclusive. Why? Because an integer is either positive or negative. Either positive or negative. Both cannot happen together. No integer can be both positive and negative at a time. You have to write no integers can be positive or negative at both positive and negative. Okay, you can pause the video to write everything. Thank you.